Field logistics workers, public safety personnel, and active content creators all face the exact same operational bottleneck. They need to record high-definition, first-person video while keeping both hands completely free. For years, the default hardware solution has been the standard chest harness. It requires cumbersome webbing, tight straps, and thick plastic buckles. It looks highly aggressive and military-adjacent, making it totally unviable for casual public use or everyday package delivery. The commercial alternative is the standard plastic garment clip, but these rely on a single high-tension pinch point. Because they lack a wide anchor base, they suffer from extreme multi-axis instability, ruining high-definition footage with violent camera sway during a normal walking gait. Both of these legacy systems fail because they rely on the wrong physical mechanics, either hyper-restrictive body wrapping or fragile single-point mechanical clamping. The SanGear device eliminates this mechanical dead end entirely by dropping straps, clips, and buckles from the equation. What replaces them is this: a minimalist sleeve that mounts directly to a user's torso without any visible bracing. Instead of wrapping the body in proprietary tactical gear, this system hijacks the user's everyday clothing, using the tension of a standard shirt or jacket to achieve body cam level video stability. To understand how a soft pouch holds a heavy smartphone perfectly steady, we have to deconstruct its three specific engineering pillars: the sleeve mechanism, the magnetic matrix, and the biomechanical placement. This architecture abandons bulky external hardware in favor of applied material science and human anatomy. True camera stabilization does not require tighter restraints. It requires an invisible, rigidly engineered structural base. The primary phone housing completely avoids hard, rigid plastic shells. Instead, the device uses a resilient, elastically deformable elastomer enclosure. This is a specific industrial design concept known as a hybrid tension sleeve architecture. The back of the pouch contains a rigid polycarbonate plate. This flat structural spine prevents the device from bending or warping under the weight of the phone, but the sidewalls are constructed from highly flexible, low-durometer thermoplastic elastomer. Rather than relying on internal springs or mechanical shims, these elastic side gussets simply expand outward to clamp tightly around a thick device. When empty, those high tensile walls instantly snap back into place, enforcing a strict compression grip while maintaining an ultra-slim profile. While the sides handle variable physical dimensions, the rear of the sleeve is engineered strictly for optical fidelity. The upper back portion features a wide rectangular cutout specifically aligned with modern multi-lens arrays. This window is left entirely open, completely avoiding the use of clear plastic covers or secondary fabric films. By exposing the lenses directly to open air, the system completely bypasses the lens glare, light refraction, and condensation fogging that renders standard pouches useless for liability documentation. Removing the plastic backing also allows the ambient air to directly cool the rear of the phone, preventing high-processing 4K camera arrays from overheating during long, continuous recording sessions. The hybrid sleeve effectively isolates the hardware's dual needs, locking the physical device down via elastic tension, while leaving delicate optics exposed and uncompromised. But a highly secure pouch is useless if it bounces loosely against the body. We have to resolve how a strapless fabric mount controls the intense downward weight and rotational torque generated by a massive modern smartphone. The answer lies in the system's structural bond to the user, achieved through a two-piece mechanism called the magnetic sandwich matrix. The first half of this matrix is a slim, curved anchor plate that rests entirely hidden beneath the user's shirt, acting as the internal foundation. The second half is the outer mounting plate, permanently fused to the rear of the neoprene pouch. Both plates feature a specialized geometric footprint embedded with complementary high-flux N52 neodymium magnets. Looking at the back of the outer plate, you map this specific footprint: a widely spaced upper pair and a dropped lower-centered anchoring node. These N52 elements generate immense attractive force, carrying enough raw payload capacity to keep a heavy phone clamped directly to steel mesh without slipping. When the inner and outer plates are brought together across a layer of standard clothing, they magnetically self-align, creating a high-pressure compression clamp over the fabric trapped tightly between them. This brings us to the actual mechanical physics keeping the video stable: torque mitigation through an extended moment arm. By deliberately pushing the upper magnetic nodes outward, separating them by over 2 inches. The system stops balancing the phone's mass on a single center point. It distributes the weight across a rigid rectangular plane. As a user walks, kinetic twisting forces normally cause camera sway. Here, those rotational forces hit the widened corner nodes and immediately arrest. The expanded footprint takes that horizontal sway and transfers the kinetic energy directly into the solid, stable plane of the user's torso. A wide, multi-point magnetic compression footprint neutralizes rotational sway with a level of rigidity that narrow, mechanical pinch clips physically cannot replicate. There is one final optical variable. Standard chest mounts are usually worn directly in the center of the upper chest. This creates the horizon problem. High sternum placement forces the camera to shoot outward. It captures excessive sky, completely missing the user's hands and the immediate ground path. Action cameras attempt to solve this by building bulky, rigid friction hinges into their chest plates, allowing the user to manually crank the lens downward. The SanGear device eliminates the need for mechanical hinges entirely, simply by dropping the chassis placement down to the lower chest and the upper stomach region. Moving the mount down just a few inches introduces a biomechanical advantage known as a fixed anatomical tilt. The anatomy of the human torso curves naturally outward right at the top of the abdomen, creating a downward slope relative to a flat vertical plane. By clamping a rigid plate to this slope, the body's curvature acts as a wedge, tilting the smartphone pocket forward and downward by several degrees. This specific downward angle points the exposed rear camera aperture perfectly at the active transport zone. It naturally frames the user's hands, the packages being carried, the ground terrain, and critical trip hazards. It achieves exact framing calibration purely through structural placement, requiring 0 adjustments and 0 moving parts to dial in the shot. The most reliable mechanical hinge is human anatomy. By targeting the outward contour of the torso, the hardware automatically corrects its own field of view. When you layer these 3 engineering specifications together, the hybrid tension pouch, the widened magnetic sandwich matrix, and the specific anatomical placement, they form a single, unified system. For delivery drivers and field workers, this directly translates into a completely zero-prep operational speed. There are no chest straps to entangle and no plastic latches to force open. The user simply slides the phone straight down through the flapless open top. The device slides in, the elastic locks it flush, and the recording begins instantly. This frictionless deployment generates a smooth, highly stabilized first-person view. The footage tracks the ground and handles rapid walking strides without violent shuddering. It delivers the rigorous data logging and liability protection required in the field, all while remaining entirely inconspicuous to the public. Instead of wearing a network of aggressive nylon webbing that alarms bystanders, the user wears a slim, unobtrusive profile that looks exactly like a premium, everyday phone case resting on their jacket. Thick chest straps, multi-piece plastic buckles, and high-tension clips are obsolete mechanical crutches masking inefficient design. SanGear proves that superior hardware engineering isn't about adding more moving parts. The ultimate form of stabilization is achieving maximum performance through a minimal, nearly invisible architecture.